So today we are starting chapter 11, and I think 11 has 7 or 8 sections. So my plan is to spend next 4 lectures on chapter 11, and then you have your exam on, and then you're going to do a review. After the review, on next Thursday, you're going to have your exam on Friday. And then you'll have only 2 classes, probably, or 3. We are going to do review for the final exam. Any final exam is on May 20, Tuesday, 8 a.m. in the morning. Any question before we start? (8 a.m. in the morning, 8 to 10, 2 hours, 30 questions. So your 5th exam will be very similar to the final exam format. You'll have around 20 questions, 1 hour, 30 minutes. In the final exam, we have 30 questions, 2 hours. So 5th exam will be a good practice for the final exam. Okay, chapter 11, we are talking about quadratic. Now, before we go to quadratic, let's start with something we already know. So quadratic means we have the highest degree of the polynomial is 2. Okay. Now, if someone asks you x squared equals 4, tell them what is x. So if x squared is 4, what is x? 2. We all know it's 2, right? Yes. But we most of the time forget there is another solution. Think logically. What number, if you square, becomes 4? One of them is 2, but is 2 the only number? When you square, it becomes 4? -2. So if you think logically, you can see both answers. What square gives us 4? The result is x equals 2 and x equals -2. Similarly, what square gives us 9? Which number square equals 9? One of them is 3, but is 3 the only number? -3. How about 7? Sorry, 49. What number when is square becomes 49? Only 7? See, also -7. And 100? 10 and -10. So if you observe, we have square power and we have 2 results. Square power, we have 2 results. Square power, we have 2 results. Square power, we have 2 results. Well, why is that? It's because when we try to solve it algebraically, we have to take the square root of both sides, right? That's how we solve it if we don't use logic. In order to solve, we take the square root of both sides. The square root and square cancel out. So it's supposed to get x, and square root of 4 is 2, we all know. But this is half correct. When you take the square root of a square, or when you take a square root of a polynomial, if you remember from, I don't know which section, the material we learned before the 4th exam, there was one question, if we have square root of x minus 5 square, do you remember what did we say? In that case, what's the answer? Square root and square cancel out. The answer was absolute value of x minus 5. It means whatever we have inside the radical, the outcome has to give us a positive outcome. So for any type of variable, any type of polynomial, when you do the square root, we're supposed to put an absolute value. It means whatever we have for x, we want that outcome to be positive. And when you pull out the absolute value, we have two choices. The result we have, that result is either 2 if x is bigger than 2 or if x is positive, or that number has to be -2 if x is less than 0. So see, that's how we have two solutions. One is +2, one is -2. And that's why anytime we get the square root of an a variable, it's supposed to have two choices, positive and negative. So most of the time we forget about that. We only put the positive result. If you only put the positive result, it's wrong. It's always two choices based on what is x is. If x is bigger than 0, or if x is on the positive side of your graph, the result is positive. But if your x is negative side on the graph, it has to be negative. Two choices. Same thing when we have x squared equals 49, we take the square root. That and that cancel out, so we get absolute value of x equals 7. In other words, our x has two choices. Either is +7 if your x is on the positive side, or the answer is -7 if your x is on the negative side. So you have two choices, +7 or -7, which you already know logically. So the main thing here is anytime you take the square root, don't forget to put plus minus sign in front of your number. That's the moral of the story. Now let's say we don't have our xy alone, we have xy minus 14, and our goal is to solve for x. What do we do? Add 14. So we get x squared equals 14. And then we square root both sides. So this cancel out. We're supposed to get absolute value of x, but you don't have to add absolute value if you write plus minus on the other side. Same as we have absolute value of x. But when you pull out absolute value, we have two choices. Either is positive 14 if your x is on the right side of the function, or your x is negative 14 under the square root if your x is on the negative side of the function. So we don't write that. Instead, we simply said, well, our answer is either plus 14 under the square root or minus 14 under the square root. Okay, the next one. What is our first step to get the x alone? We add 24. So we get x squared is 24. And then square root. So they cancel out. We have x equals plus minus square root of 24. But can we stop here? No, because 24 is reducible. Can you divide 24 by a perfect square number? 4. So anytime you can reduce, you must reduce. It's square root of 4 times square root of 7. What is square root of 4? 2. So we have x equals plus minus 2 square root of 7. It means our answer is either x equals 2 square root of 7 or negative 2 square root of 7. Exactly, it's 6, not 7. Come on, thank you. 4 times 6 is 24. 7 times 4 is 28. Yeah, let me fix it. It looks like 8. $14, we didn't do anything because 14 is not reducible. We cannot divide 14 by 4 or 9. But we can divide 24 by 4, so we have to reduce. Anytime you have something reducible, you must reduce. Okay, now the last type of scenario. What if we have not x squared, but something next to the x? So what is our first step to get the x alone? We have a square, right? So first we need to get rid of the square. We apply the square root on both sides. Square root, square cancel out. So we're supposed to get absolute value, but you don't have to write it if you put it the plus minus sign on the other side. And then to get back, so what is the last step? We add 1 to both sides. So we have x equals plus minus 1 plus 1. It looks weird, so we have to separate them. Our x is either plus 1 plus 1 or it's minus 1 plus 1. This is what it means. If it's plus 1 plus 1, we get 2. But if it's plus 1 minus 1, we get 0. In other words, our solutions are either x equals 0 or x equals 2. What do we do in the next one? It looks same, but they're not same. First step with the square root because our x squared term is alone. So we have x minus 1 on one side. What is square root of negative 1? Really? What is square root of positive 1? Square root of positive 1 is 1. What is square root of negative 1? Huh? Square root means find same number, multiply twice, it becomes the radicand. So square root of 1 is 1 because 1 times 1 is the 1. If you say negative 1 times negative 1 is? But we are looking for same number, multiplying twice becomes negative 1. Not possible before, but not now. It cannot say not possible anymore.
Oh, you have to imaginary number.
It becomes I. How could you forget? We did so many I example in our last class. Square root of negative 1 if the imaginary number I. So you cannot say it's DNA, it's I. And then you add 1 to both sides. So we have two choices. X equals I plus 1 or x equals negative I plus 1. Because our I has two signs, plus and minus. So plus I plus 1 or minus I plus 1. We do have two solutions, but these are imaginary solutions, not real. So you see, when you take the square root, there are three choices. Either we get something that is not reducible, so four choices. Either we have something that is not reducible, or we have something that is reducible, or we have a whole number, or we have imaginary numbers. So square root has four choices when you solve for it. Now, since we know how to solve square problem or quadratic problem, now we want to know how many ways we can solve them. So we already learned one method, which is factoring. Anytime you have a quadratic, if it's factorable, we can factor and we solve for x. Now, let's say we have something that is not factorable. If something is not factorable, then you have three choices. Either you graph it, which is kind of harder if it's not factorable, or you use quadratic formula, which you already know, or there is a new method called complete the square. So when you solve any quadratic, whatever you get for x, like all these x's, we call them either the x-intercept or the root or the solution of the quadratic. Anytime solve for x means you're solving for x-intercept, or you're solving for the solution, or they're the root of your quadratic. Now, many people forget about which one is quadratic equation and which one is quadratic function. Quadratic function is when you have y on one side and your equation on the other side. On the other hand, in an equation, if you have a number or x on one side, we can solve quadratic equation, but we cannot solve a function. For a function, we can factor it, but when you have an equation, you can factor and you can solve. That's the difference between function and equation. Function is just function. We can rearrange a function. But when you have an equation, you can rearrange, you can solve, you can do everything for an equation. And like I said before, we already know the factoring method. If it's factorable, we use either GCF or factoring by two terms, perfect square, SE method, all these things. If it's not factorable, then you have problem. You can use any one of the three. Even if it's factorable, you can still use any one of the three or any one of the four. It doesn't matter. Now complete the square. When you complete the square, our goal is to rewrite this in this format. X and then plus minus something and then square. So it's called complete the square, means from here we want to complete a square so that we can easily take the square root and solve. So how can you rewrite this as that? Mathematician says easy. All you have to do is that something is half of your beta. If your A is 1, as long as your A is 1, then this something here is half of the beta, and then you can complete the square. That's it. That's all you need to do. Now let's start with something we know. Oh, my name is too small. Anyway, so if we have x squared plus 8x plus 16 and you want to factor it, two numbers multiplied to 16 combined to 8, we have x plus 4, x plus 4. It means you have the same thing twice, right? Now, if you only want x term together and not the constant term, we can subtract 16 from both sides. So we get x squared plus 8x is that perfect square minus the constant term, right? Now look at another example. X squared minus 6x plus 9. If we factor, we have the same factor twice. So it's x minus 2 squared. But if you want only these two together, not the constant, you can subtract the 9. And we get x squared minus 6x equals the perfect square minus the constant. If we have a fraction, no problem, we can do the same thing. Two numbers multiplied to 9, 4 combined to 3 is 3 half. 3 half and 3 half, when you multiply them, they becomes 9 fourths. If you add them, you get 6 half, which is 3. But if you want only the x's together, we can subtract the 9 fourths from both sides. So we get x squared plus 3x is a completed square minus the constant term. Now, do you observe something? This 16 is that number squared. Did you notice that? We are subtracting that square. Here we are subtracting 9, but what is 9? 3 square. We are subtracting 9/4 here, but what is 9/4? 3/2 square. So we are always subtracting the exact amount, the square of the exact amount we have here, right? Also notice something. This thing is exactly half of our beta, right? 4 is half of 8. Also here we have 3. 3 is half of 6. And here we have 3/2. 3/2 is half of 3, right? So when we have 2x term, we can complete the square by taking half of that amount and subtracting the same amount squared. You see, all of these examples, if you have only these two given to you, we can complete this as a square by adding this amount square, sorry, half of this amount, and always subtracting that square. Whatever we are adding, that square. If you have only x squared minus 6x, we can complete our square by taking half of that and subtracting that square. In other words, if you are given only two x terms, one is x squared and one is bx, we complete the square by taking half of the b term inside the parentheses, complete the square, and subtract the same amount you have inside your parentheses, square. Is it confusing? Let's take the example. Let's say you're given only x squared plus 2x, and you would like to complete our square. So we're definitely going to have x, and then we need to do something extra here. What goes inside the parentheses next to the x? How much? Good job. We take half of that, so it's plus 1, and then we have to subtract what? 1 squared, which is 1. Wonderful. We complete our square. Who would like to do B? What goes inside the square if you have x squared minus 16x? Sergio? Minus, because we have minus here, minus, or B is minus, right? So we take half of that amount, which is minus 8. And then what do you subtract? That amount squared. So what is negative 8 squared? Negative 8 times negative 8. 64. You add half of B, but you subtract half of B squared. Who would like to do C? X squared minus 50x. So it will become what? So x squared plus 50x. What goes next to the x? Plus 25. This time our B is positive 50, so you take the half, it's positive 25. Plus 25. And how much you are subtracting? 25 squared, right? What is 25 squared? Do you have any idea? 625. We are adding half of B, but we are subtracting its square. And now the last one. We have x squared minus So it's negative 11 over 2, half of 11. And how much you're subtracting? That's square, right? So what is 11 squared? 121. And what is 2 squared? 4. So it doesn't matter if you have a fraction or whole number. Always take the half of b and you're subtracting that amount squared. But in order to do that, our condition is a has to be 1. We cannot have any number in front of x squared. If you do, there are two choices. Either see if it's divisible by, if you can factor out, or if it's divisible by something. So you have to factor it out fast or divide both sides by the same number so that your x squared becomes 1. So your a become 1. Okay, so that's how we factor. So now let's do some example. We have x squared minus 8x plus 9. That 9, we don't care. Oh, first of all, it looks like it's factorable, right? Can you factor it? Two numbers multiply to 9 come back to negative 8. It does sound like it's factorable. 9 times 1 is 9, 9 minus 1 is 8, right? But look what happens. 9 times 1 is 9, 9 minus 1 is 8. We want 9 to be negative. So if 9 is negative, 1 has to be positive. So minus 9 plus 1 gives us minus 8, which is the middle term. But if you multiply minus 9 times 1, what do you get? Negative 9. But what do we have? So is it factorable? So it's a tricky question. It looks like factorable, but actually it's not factorable. So we don't care about 9. 9 is useless here. We only look at x squared minus 8x. What do we have? How can we convert into a perfect square? What goes next to the x inside the parentheses? So definitely we'll have something like this, right? What goes inside the parentheses? Perfect. And what goes outside the parentheses you're subtracting? 16. So we completed our square just by observing our x terms. And this was already given to us. So we did nothing here. We kept our 9. Equals 0. Now these two are like terms, right? They're numbers. So we keep our perfect square. We are very happy. And how much we get from minus 16 positive 9? 7. Minus 7. Perfect. And now this example is exactly same as what we did before. Right? See here, this page. It looks like this type of example. So what is our first step to get the epsilon? Add 7. We don't need this bodyguard, so we get rid of it. We get x minus 4 squared equals 7. Next step, we don't want the square, so take the square root. So we get x minus 4. We're supposed to get an absolute value, but instead of writing absolute value, what do we write? Plus minus on the other side. Square root of 7. Another last step is to get the epsilon, add 4. So we have x equals 4 plus minus square root of 7. You can rewrite x equals 4 plus square root of 7 or x equals 4 minus square root of 7. Either one is fine. We cannot simplify, so either one is fine. But if it wasn't square root of 7, only 7, you must write it this way and you simplify. Question? Okay, then you try one. This time we don't have x squared alone. So what is your first step? No. We don't want x squared to have any number in the front. So you have a 2. What can we do now? We can take out a greatest common factor, or if you observe all these numbers are even, so what can you do? Divide by 2. So you factor out, either you can factor out and divide, or you can divide at the same time. So let me just do the first step for you guys. We get x squared minus 4x equals, what is half of 44? 22. And now we can complete the square and solve for x. Oh, let me put that in that. And then I have one more. Today is for 29. Eliza is here. Fabricio absent. Saju here. Miley here. Oliver here. Himadri here. Mustafa here. Jacqueline here. Jia here. Anaya here. Atsiri here. Sitlani here. Saida here. Mohammed here. Ronaldo here. Danielle here. Jeremiah here. Camila here. Almost everyone is here except Fabricio. So why do you have 0 or factor and stuff, right? And here we already factor. That means our goal is to solve. Minus 4? Oh, 6 minus 4 should. And then Right, the direction is square alone. Just like the radical. You know, under the square radical to be alone. Same thing concept the ratio. That's why it has to be at least integrated into. So see, here's the integrate. So here should get all the difference instead of adding things. See, no problem. So, and then it's not really so
And then I get to.
so you know, typically square, you get square, and then you get square. And that was- Just up to- Now you say anytime you're making up the square, and then you have two sides. Remember the numbers, two and your time is all. What's that? So you have I and then square times two. And negative times into I. And now 18, can you start with 18? Nine, 7 minus 1. Three I was and the next one. Can you combine them? On your right, like given the past. So 2 plus minus. This one is plus minus, right? For I. That's one, you subtract this one, right? So you can subtract it. So any negative number can be divided. Square. I was doing last picture square can be wrong. So you have
So. Any given function that gets equation, it is not that.
You don't have to, but if you can, you get two choices. Either use this number or working formula. You're going to do a working formula later. Class, I'm showing you this method.
So like, you could solve by the
And what is the square root? You will get like
Okay, so in this case.
Taking a square root. And this two has square, right? So square is square is one. And then when we have it's a using. Let's do that together. Since you don't have much time.
Yeah.
So inside we take half of b. It means we divide b by 2, we get -2. And then outside we subtract that square, which is 4. Now our goal is to get the x alone. That means we need to get rid of the -2, the square, and -4 one by one. We start by taking out the 4. We add 4 to both sides. We get x minus 2 square equals -18. And now we have -2 and square power. Square power is far from x, so we take the square root. Square root, square cancel out. We have no more square, only x minus 2. But on the other side, it becomes unreal number. We have square root of -1, square root of -9, +9, and square root of 2. We split our 18 into 3 pieces. Because -1, you have to pull it out, it becomes I. And then you have 18. 18 is 9 times 2. So we have x minus 2 is I, 3, and square root of 2. The last thing we do is add 2 to both sides. So we get x equals plus minus 3i square root of 2 plus 2. Or you can write x equals plus minus. We have to write the real number first. So 2 plus minus 3 square root of 2i. Either one of them is fine. So whatever we did in our last class, we are doing the same thing here. We are reducing our imaginary number. We are converting this into imaginary number and then we are simplifying it. Similarly, the next one we have x something square minus, and then we have plus 5 equals 0. So what goes inside? What happened to what? So we added 2 to both sides, right? So this is our added 2. So 2 has plus sign in the front. So we put 2 in the front.
Okay.
And we have to write this as a plus bi format because this is complex number. So real number first and then the I number.
So you don't add.
We cannot because 3 is not alone. It has square root and I. So what goes inside our parentheses next to the x for the next question? Minus 3 over 2. And then you subtract how much? Good job. 9/4. We take the half of b, including its sign, and then we subtract the same thing square. These two are combinable, so we combine them. Here we have x minus 3/2 square. And in order to combine them, we want to have the same 4 here so that we can have the same denominator. That means you also have to multiply the numerator by that. So we get minus 9 plus 20. That gives us plus 11/4. X minus 3/2 square equals 0. X minus 3/2 square equals 0. Just like the last one, we have x. We want to get this alone. So we have 3 problems. One is this, that, and that. So we start one by one. First, we get rid of this thing. So we subtract. We get x minus 3/2 square equals negative 11/4. Next problem is the square. So we take the square root. Square root cancel out. We have x minus 3/2. And just like the previous one, we have square root of -1, square root of 11 over square root of 4. We split our square root into 3 pieces. So we have x minus 3/2 equals I. Square root of 11 is square root of 11. We have no idea. But what is square root of 4? 2. And we cannot forget about the plus minus sign. Anytime you do the square root of a variable, we always have 2 choices. And then the last thing we don't want is a 3/2. So we add the 3/2 to both sides. But 3/2 is a real number. So when we write, we want to write the 3/2 first, and then plus minus I square root of 11/2. We cannot combine them because they are not real. If you find this method is hard, no problem. You have one more hope. A quadratic equation. Sorry, a quadratic formula. Complete the square. If you don't like complete the square, then you go to quadratic formula. Quadratic formula has 2 problems. One is first you have to memorize it correctly. If you don't memorize it correctly, you get 0. Second problem, if your ABC are big numbers, quadratic formula doesn't help you because you get square root of a big number and then you have no idea what's the square root of the big number. So that's why every format has its own benefit and downside. Complete the square has a downside. If you have a fraction, you need to combine them, so it becomes harder. Quadratic formula gets problem when we have big numbers to begin with, like ABC. But let's do one example of the quadratic formula. Let's say we have this quadratic equation, we have this quadratic function, and we want to get the x-intercept of this function. It means solve for x. So our x is negative b plus minus square root of b square minus 4ac whole thing divided by 2a. You must memorize it correctly. If you forget, that's it, you cannot use it. And also, in order to use the quadratic formula, you have a condition. All three terms must be together. Like this one. Ax squared, bx, and c, they are together. So you have to have them together in order to use the quadratic formula. So we identify what is a, what is b, and what is c. In this function, what is a? No, a is a number. It's 1. A, B, C, all of these are number. X, Y is a variable. It's not a number. What we have in the front, that's A. What is B? Negative 4. What is C? 10. So ax squared, bx, and c. So you have to correctly identify ABC, correctly memorize the formula, and then correctly substitute everything. So negative b means what? Negative, negative 4. So you have double negative. Plus minus negative 4 parenthesis square minus 4 times 1 times 10 whole thing divided by 2 times 1. The double negative turn into positive. So we get 4 plus minus. What is negative 4 parenthesis square? Positive 16. And we have 4 times 1, 4. 4 times 10 is 40. So we have 16 minus 40 divided by 2. So 4 plus minus. What is 16 minus 4? Sorry, 16 minus 40. Negative 24 over 2. And now let's split them. 4 over 2 plus minus negative 24 under the square over 2. Why did I split? Because this is reducible. What do you get from here? Square root of negative 1. And then what two numbers gives you 24? 4 and 6. So what is square root of negative 1? What is square root of 4? And do we know what is square root of 60? Square root of 6? We don't know, so we keep it. That means here we get 2 plus minus 2i square root of 6 over 2. That negative 24 under the square root becomes 2i square root of 6. But then you can cancel the 2 with the 2. So final answer is 2 plus minus I square root of 6. Or 2 plus minus square root of 6 I. Why this is straight. Any question? So see, for one quadratic equation or function, we have, if it's not factorable, then complete the square or use quadratic formula. It doesn't matter which method you use, you must simplify anytime it's simplificable. If you can simplify, you must simplify. If it's not simplificable, leave it alone. And guess what? In the final exam, they will ask at least one of these, where you choose either quadratic formula or complete the square. They will not mention which method. It's up to you which method you want to use. Question? Now, quadratic formula, we love it because of another reason. Let's say you don't have time. You don't have time for any reason, but you want to know how many solutions you're going to get for your quadratic equation. Well, without solving the entire quadratic formula, we can figure out how many solutions we're going to have just by looking at the term under the square root. The terms under the square root has a special name, it's called discriminant. And just by observing a discriminant, we can figure out how many solutions you're going to get, how many x-intercept, or what's the shape of your graph. Now, if that discriminant is a positive number, we have negative b plus minus something square root over 2. Since you plus minus, so we have 2 real solutions. It means we have 2 x-intercepts. Now, if your A is positive, then you have, for this case, you have a graph, something like this, where you're crossing your x-axis twice. But if your A is negative number, then your graph will have this shape. Again, you're crossing your x-intercept twice. So just by looking at the discriminant, we can only figure out how many x-intercept we have and how our graph is crossing the x-axis. If that discriminant is 0, so this entire thing becomes 0, so you have only negative b plus minus 0 means only negative. So negative b over 2a means only one solution, one real solution. One real solution, that means you have only one x-intercept. So if your A is positive, that means you have a graph that is only touching the x-axis. It's not crossing. That's why you only one real solution. But if you're upside down, it means you have something like this, where you are crossing, you're not crossing, but only touching your x-intercept x-axis. So you get one real solution with one x-intercept. And in the last scenario, if this thing is negative, just like this one, if it's negative, see we have 2 solutions, one is positive, one is negative, but this term is imaginary. So we get 2 imaginary solutions, and since they're imaginary, they're not real, so we cannot have any x-intercept. What does that mean? It means either your graph is lying above the x-axis if your A is positive, or it's lying below the x-axis if your A is negative. You're not crossing the x-axis, so there is no x-intercept. Why? Because you have imaginary solution, not real. So discriminant tells us all this information. In our next class, we are going to do a few examples with the discriminant, and then we are going to do some equation that don't look like quadratic, but you can solve them using quadratic methods. And that's all for today. Thank you so much for being here. Have a safe day. See you all Thursday. How are you today?
I'm doing good. It's just I found.
Sure. So you missed whatever you missed. I already posted the lecture video.
I'm gonna watch it.
Mhm.
Okay, great.
Thank you. Be safe.